Okay, so everyone, I hope you're all doing well. I know this is the first talk after lunch. Some of you might be a bit tired. I just had a whole francesinha before this talk, so I'm like, okay, let's use that to power me through the presentation. I hope none of you fall asleep and you're all ready for the rest of the day. So before I start doing this presentation, because this might kind of be of a follow-up, even though it's not a follow-up, but who was here last year? Okay, and did you watch my talk last year? Okay, cool. So you did, none of you watched my talk last year, because last year I did an introduction to SolidStart, and when it was in alpha. Now it's already released, so it's gone. If you had been here last year, you would have a comparison to how it changed from the last year, but don't worry, you definitely didn't have to be here last year. So I want to start this talk with 3 questions, in a sense. First question is, who here has heard about SolidJS? Okay, cool. My second question here is, who here has used SolidJS? Okay, interesting. And my third question is, who here has watched the movie Dune? Okay, now some of you are very confused. Yeah, because I'm going to make some comparisons if you have watched Dune. If you haven't, it's okay. The point we're trying to make here is that 6 years ago, when SolidJS showed up, it showed everyone the path. And this was a path of reactivity. More specifically, fine-grained reactivity. You see, this is where we were 6 years ago. SolidJS, being the JavaScript framework, library, whatever you want to call it, we're not going to go into that discussion today. Let's call it a framework for our sake's purposes and not having to discuss stuff. When SolidJS showed up, it was all being the most fine-grained reactive framework that we had, whilst everyone else was here. Now, some of you might be wondering, what the heck is a fine-grained reactivity word? Or sentence, what the heck does that mean? Personally, for me, as a Portuguese native, I was like, how do you translate that as well to Portuguese? It doesn't make sense. But it kind of starts with an architecture. For you to fully understand what fine-grained reactivity is, you have to understand these 3 base architectures. And we start with a pool-based architecture. When we have this type of architecture, we have a data, and we have our component. And the way this thing works is the component asks the data, is there any updates? The data doesn't reply. He asks again, is there any updates? The data doesn't reply. He asks again, is there any updates? Okay, now we have updates, so we pull the data. This is very similar to what React does. React is a pull-based architecture. Then we add the second one, which is push-based architecture. And the way push-based architecture works is the component is always listening to the data, and every time the data changes, it's pushed into the component. So this might be a bit what RxJS does. Now, there's some issues or pains that you might get with these 2 types of architecture. When you have a pool-based architecture, you have to implement kind of a pooling mechanism, because your component needs to always be checking, is there any data changes, is there any data changes, is there any data changes, until the data actually says, okay, there's changes, and then it pulls it. When you have a push-based architecture, then you get into another problem that's called back pressure. You might lead into an issue where your data is being sent so fast and in so many quantities that your component cannot handle it. So you have to implement a mechanism for the component to figure out, hey, calm down, and let me just process what I have to do, and then I'll get back to receiving the data. And these have been 2 fundamental issues, mistakes, whatever, not mistakes, issues, when dealing with pull and push-based architecture. And this is when we started talking about push, then pull architectures. And the way this works is the data says, I updated. And then the component says, okay, please send it to me. So what happens instead of just pulling it directly, the data says, hey, look, there's updates. It signals there's updates. And once the updates happen, the component pulls the data. And this is kind of one of the architectures that will lead us into having fine-grained reactivity. So if you have used React, pull is use state. I didn't put it here, but push is basically if you're using something like observables. If you have used any signals like library, that creates signal. So these are the implementations of these architectures when we start talking about them. Now, when you have a push then pull architecture, it's important that it obeys two rules. The first one is these systems need to be efficient. It means that they only should execute what's necessary. What do I mean by this? It means that only the specific parts of the UI that depend on that source of data should update when an update happens, instead of the whole UI updating because of a single state, whatever, a number that updates. So efficiency means that only update only updates whenever that data source changes. Second, glitch-free. So it should be glitch-free, which means it should never show any intermediate state. A very good example of this, and this kind of means that you shouldn't have any state tearing. A good example of this is, imagine that you have like the GitHub UI. So one example of state tearing would be, you're in a pull request, and then up there it says, 7 open pull requests. You go ahead and you click on merge. That pull request has been merged, but the UI still shows the 7. This is an example of state tearing. It means that your UI is not free of glitches. It's basically your state is not reflecting where it should be reflecting. And these are the two rules that you definitely need to have when you're having a fine-grained reactive system, which implements the architecture push then pull. So, in a sense, this is the mind map for you to understand. Push then pull, it's the architecture. Signals, it's an implementation of push then pull. And as a consequence of that, you're going to have fine-grained reactivity. And this has been kind of the concept that changed the JavaScript framework world in the last few years, because remember where we were in the past, so I'm going to go back a bit. This is where we were 6 years ago. Now, and I should pass this first. I forgot I had animations. Now. Okay, this is where we are. So, as you can see, almost all the JavaScript frameworks saw the value of fine-grained reactivity and refactored their code base in some way to introduce signals. Angular just added signals. Quick has had signals since the beginning. Svelte introduced runes, which is basically signals. Vue, now with Vue 3, they're going to also, or they already introduced signals. So all of the frameworks are starting to converge into this mentality that fine-grained reactivity, it's actually beneficial for us building our UI and our web applications. Almost everyone saw the value of it. Now, while this was happening, another discussion started showing up. You see, in 2021, 2020, something like that, we remember that servers existed. And we were like, oh, maybe we should start getting stuff rendering on the server again and sending it back to the client, like we used to do in the back old days. Now, we are doing single-page applications everywhere. Our applications are fully controlled by JavaScript. If JavaScript fails, our apps blow up. Let's start server-side rendering again. And one of the ways to bring server-side rendering to your applications, besides configuring a Webpack file, which was awfully painful, was to adopt a meta framework, a sandworm in this case. So every framework had their own meta framework. It's called meta framework because it's a framework built on top of a framework, therefore the name meta. So Vue as Nuxt.js, Angular as Analog, React as Next.js and Remix. Now they're going to have 10-stack start as well, which is coming up, which the beta phase was announced last week, so it should be coming out any month soon because Tanner works very fast. Either way, meta frameworks were a good way for you to have server-side rendering in your applications. It was not just about the deployment adapters, the better developer experience, and the stuff that meta frameworks brought to us. It also had these multiple rendering modes. Now, one question that started showing up in people's minds was, okay, what about Solid? Are we stuck configuring Webpack files? Where's Solid's meta framework? Well, in 2021, Vite 2.0 was released. And on that precise week, Ryan Carniaro, the creator of Solid, started to work on Solid's meta framework, SolidStart. And this is a bit of where this presentation will start. Sorry. Before I start this thing, let me just introduce myself, because I've been talking for 10 minutes and I haven't introduced myself. That's rude. My name is Afonso. I'm a senior developer advocate at PagerDuty. I'm an instructor at Hagad.io, and I'm part of the SolidJS DX team. So I am biased about the stuff that I'll be talking today, because I've been helping at least shape the experience that developers have when using SolidJS and SolidStart. Some other stuff about me. I don't do just Solid. I like React. I actually wrote a book about React Query last year, State Management with React Query, which React Query was, and it still is, one of my favorite libraries. Tanner Winsley, the creator of 10-stack Query, did an amazing job with it. It's by far my favorite solution to manage server state, but that's not what we're going to be talking about here. I actually like testing as well, very much. So I released on Hagad last year an introduction to React testing library. I just released last month? Yes, last month, an introduction for SolidStart, which basically just takes you over some of the APIs. This last course is fully free, so if any of you want to go check it, it's open for everyone. You don't need to pay anything. And if you want to be updated to what's happening in the world of SolidJS, I've been releasing a newsletter every month called This Month in Solid, where basically I compile every updates that we got from core, updates we got from the ecosystem, stuff that shows up online, where me and some of the people from Solid team and people are doing content about Solid are going to be, and some stuff, in case you want to find them in this world. So This Month in Solid, now we are finishing the month, so I need to start working on next week's newsletter. But yeah, I've been releasing this at the end of every month. So enough. Oh, and you can find me at any social network at the handle Daniel GC Afonso if you want to connect or ask me questions after the presentation. So the question: why do we need a meta framework? Because that's okay. I told you that a meta framework was a way of having server-side rendering, which is true. But a meta framework, it's more than that. It's about having a faster time to production. This can be through having multiple rendering modes. It can be through having an improved developer experience, proper guidelines, deployment adapters, and it's about being opinionated. These are some of the things and sentences that kind of go side by side with meta frameworks. Now, there's a word here that JavaScript people don't like, or at least the ones I've met in the years I've been doing this, which is opinionated. Because being opinionated means that your framework is going to be opinionated on what you have to do. It means it's going to lock you into certain conventions. It means it's going to tell you, you should use this. And for our friends and from the JavaScript community, this kind of feels like I don't have freedom. It feels like, okay, I'm being locked in. Why can I not replace this router for another one of my choice? Why am I stuck to the choices that someone else made for me when building this framework or meta framework or whatever? It kind of feels like there's a comparison here somehow into how JavaScript community kind of is afraid of relationships, and being opinionated is you're in a relationship with the choices that that framework makes to you. Take that however you want, but that's kind of the general feeling that I've been feeling and heard people say when talking about frameworks. I have an example. Remember when, it was 2 years ago, there was this framework who released the version 13 and changed their router. And everyone lost their minds because they didn't want a new router. They wanted to use the old one. They were like the old one. So now they're locking me into a new choice that I never had to make, because it was either that or you couldn't use React server components. That's another discussion. Either way, when talking about frameworks, there are parts who are most opinionated, which means that are going to have more decisions and are going to lock you in more opinions and decisions. The router is typically the part of the framework that's the most opinionated, because that's the one where most decisions happen. That's the one that's harder to push changes without breaking the entirety of the rest of the meta framework. It's chaos, trust me. I was not aware of how much a router was important to a meta framework until I had to start working with SolidStart. Then we have the framework, Obviously, that's going to be opinionated. You either use one or you don't use, or you use the other, but that's going to be opinions. React does stuff differently, Solid does stuff differently, Angular does stuff different. They all have their own opinions. Then we have the parts who are least opinionated, stuff like the bundler and the server runtime. And with this in mind, I want to take you back to the what about Solid part. Because since May of this year, SolidStart is stable. SolidStart has been released, is production ready, and you can start using it shipping full stacks Solid applications. Now, the reason why I asked you in the beginning if you had been here last year, because when last year I was here at Porto Tech Hub, I was delivering a presentation about SolidStart. It was still in alpha, so a year ago. And in the between, there was a major rewrite. So we rewrote everything that I presented last year. We changed the entirety of the meta framework because we wanted SolidStart to be a starter, first of all. But we wanted SolidStart to be kind of a choose-your-own-path type of thing. This could be a slide from an inspirational or from a coach presentation. It kind of could be, but it's about SolidStart. Because what we mean by this is we wanted SolidStart to be a place where you can start building solid applications without being locked in. And this is the interesting part here. SolidStart is not opinionated. You don't even need to use Solid Router, which, remember, I told you, the router, it's the most opinionated part of every meta framework or framework. SolidStart is meant to be a journey starter. It means to be, you start with a basic Solid application. If you want to add Solid Router, you add Solid Router. If you want to build your own router and bring your own router, you should bring it. The only difference here is that your router needs to speak with SolidStart, which at the end of the day is just sending a JSON object and it parses it. So there's not a lot of difficulty there once you have a router working. But it's about building your own choices, because when you're working in production, teams are going to have different opinions. Your company is going to want to use a specific design system. They're going to want to use a specific router. They're going to want to use a specific library. SolidStarter is meant to be customizable before anything. And then if you want to be opinionated, obviously you're going to have the best developer experience. That's obviously the catch here. But you shouldn't suffer from decisions that the creators of the framework made for you. Now, this is a SolidStart application. This is basically the art of everything. At the top level, we have Solid Router. And remember, this is optional. You can take Solid Router out of the equation. This is just basically a full 100% full 100% usage of SolidStart example. So we have Solid Router, which is a router. We have Servo, which is our serializer. So it's a full stack framework. It works on the client, it works on the server. We need to send stuff over the network from the server to the client. There were some specific use cases that other serializers had from other frameworks that didn't work for us. So like serializing processes in flight, that's a very complex thing, which to this point I still fully don't grasp at all. To be honest, there's like 3 or 4 people in the Solid community that can explain Servo like from scratch. But the catch here, the point here is it's a serializer. It's what basically allows us to send data over the wire. And then we have our framework, SolidJS, obviously. And then we have Vinci. So Vinci, it's a wrapper over Vite, which is our dev environment and bundler, and Nitro. The reason why we built Vinci, so Vinci was built by a core member of Solids, Nick Hill, and then now he's helping using Vinci in 10 Stack Start. So if any of you want to check 10 Stack Start eventually or are in the React world, 10 Stack Start also uses Vinci. Basically, it allows you to build customizations for every environment where your application is going to run. There's more to it, but the gist, it's a wrapper over Vite and Nitro. Vite, it's the bundler that most applications are using nowadays. By far, it's the most easy customizable. Wow, my English service stopped working. More easily customizable. And then we have Nitro, which is our server runtime. So the reason why we went with Nitro, it's because it's fast enough and strong enough to power things like Nuxt. It's fast enough and strong enough to power things like Analog. And not just because of that. One of the things I've been noticing a lot since I've joined the Solid community is there's this need for help between frameworks. If any of you have ever seen Ryan's streams or have followed him online, you should be aware of how much he's always giving into the community. And adopting into something like Nitro was a decision that made sure that we are always helping each other. If anyone from Next fixes an issue with Nitro, it's going to help Solid. If anyone from Solid fixes an issue in Nitro, it's going to help Analog and Next. And then we have the communities working together and helping each other grow. So everyone has the best frameworks or meta frameworks that they want. So this, in a sense, it's the heart of a SolidStart application. Now, some of you might be thinking, okay, what about features? Because you have been telling me about the framework and how it works for a long. What features do we have? Well, during this presentation, I think we're going to see almost all of them right now, because now I'm going to go to Visual Studio Code and show some demos. If I don't know if we're going to have time to show you optimistic updates, but that should be fairly easy to showcase in another example. So we have 30 minutes. Okay, there's a lot of time. We can take this calmly. So we're going to build an application. Let me just put this full screen. Zoom in a bit. This is an app where you can add a user to an on-call rotation. Just something a lot of people don't like, being on call, but I work at PagerDuty, so I'm going to put on call here because that's some of the things that we work. Either way, in this application, it's very straightforward. We have our index page. That's what we have here, localhost 3000. When I click on an example, I go to the route on-call/ID of this rotation. Here I can also see some information. I can go back and I can add a new user to the rotation. So I can come here, I can say a service, so what shall I call service? It can be checkout service. Thank you, autocomplete. The user, let's do Bruce Wayne, like Bruce Wayne. And let's put Bruce Wayne from on-call from tomorrow at this precise time until the 5th of December. At about the same time. So we add him to the on-call rotation, and this here. This is the application that we have built, and we're going to see how it works with SolidStart. So let's start this thing. I'm going to zoom a bit. And people in the back see this well? Thumbs up? Okay, cool. And if you need, let me know that I'll zoom in. Oh, this is kind of, no, but it's okay, you can see properly. Let's not start here. Let's start in our app config. So our app config here, it's basically our Vinci configuration file. It's basically a wrapper around Vite where you can define plugins, you can customize stuff. Here there's a definition that says we're going to do server-side rendering. I'm going to turn this off. We're going to do a single-page application like we're used to with plain old create React app or whatever, even though that thing is dead. Either way, let's start with a single-page application. So here we have some points. We have the entry server, which is basically what the entry point for our application when we're doing server-side rendering. This is not very interesting at all, so we're not going to go over it. Here we have the part when we're doing hydration that the browser uses when doing client-side rendering. And then here is the art of the application. Before we go into the art of the application, let me just show you this lib folder. This is basically, let's assume this is a database. I have an use unstorage here, which is basically just a key value pair thing that exists on my server, which is supposed to be my simulation of a database. So inside of this database, we have some data which is pre-populated, and we have an on-call file where we basically have a function to get a single on-call, no, to get a list of on-call, a function to get an on-call by a specific user, and a function, an action to add an on-call. We'll go over what these things and what the other things mean in a bit. So let's start with the app.tsx, because this is where every application with SolidStart starts, pun not intended. So we have a router, and here I'm using Solid Router because I'm trying to get the most of these experiences I can. Like I told you, if you want, you could bring your own router. But the reason why I'm using Solid Router is because it's going to allow me to do some very, very cool things up ahead, which are some of the perks of using it. So in this router, we're doing a couple of things. First of all, let's start with file routing. What we are doing here, what we would traditionally do here is but if we didn't have file system routing, is we would say route index, which is the slash. Then we add the component where it would point to. And whenever the router figured out it was on that route, it would render it. We would add route slash on-call slash dynamic ID. And when it would find that route, it would render it. And we would be doing this manually and by hand for each specific route that we would have. This is the first issue, which is a non-issue. The second issue is when stuff starts getting a bit tricky is we want to do tree shaking. So a way to do that is by doing lazy loading components. So for each specific component that we would be rendering here, we would have to import lazy and say this component is going to be lazy loaded. So so it's only loaded whenever that route is rendered. Therefore, we avoid having everything in our bundles and sending everything to the client also altogether. File system routing fixes this issue by, before anything else, allow you to look at your folder structure and depending on your folder structure, rendering your components. So what I mean by this is, what it's going to do, it's going to look into, let me close this, into your source and look for a folder called routes. And inside of the routes folder, it's going to say, okay, do I have an index? I do. So what's being default exported from this index, which is the base route, it's going to be turned into the index page. So what this component actually is, it's this page, the index one. So it's turned into the slash route. Then it's going to continue looking. Okay, we have a component called new. So this component, there's no parent, so it's not inside of any folder. So this component is going to be turned into the new route, which is the one that we have here. Secondly, it's going to continue looking. Okay, we have a folder called on-call. Cool. There's something here, but what's going to happen is it's going to render what's inside of here on-call slash something. Now you might be wondering, what's this ID thing? Well, this is called dynamic routing. The reason why this exists is every single one of these things has an individual ID. So this is 0, this is 1. The more I keep adding, the more IDs are going to happen. I'm not going to create a route for 0, 1, 2, 3, 4, yada, yada. The dynamic route, what it does, it catches anything that goes inside of on-call, injects it into the component's parameters, and then the component can use it to fetch data dynamically. That's basically what a dynamic route does. So basically what's going to happen here is that this one that's here, it's going to be the ID that's going to be injected into this part. Some other stuff besides doing this. File system routing is also smart enough to figure out which routes are needed, what stuff can be automatically lazy loaded. So it already does that wrapping of lazy automatically for you, so you don't have to worry about that. So there's already wins here. Obviously, some people don't like the folder structure. Like everything in development, it's a preference. You don't have to use file system routing. You can just go back to your own, you can just come back here and say, okay, now I want a route. And then you can customize your route manually. It's a choice, but there's benefits in leveraging file system routing. Now, what's going to happen as well, because you've seen me rendering all of that stuff, but how does it actually work? The way it works is because there's this thing here called suspense. So suspense is an util for doing asynchronous data loading. So in a sense, what this is doing here, it's telling the router, hey, whenever you find a route that you're going to load, and while you're loading, I'm going to render this fallback. And once you finish loading, so once that component, once that component is ready to be displayed, I'm going to render and show it here. So this is basically what suspense does. And when it finds that something inside of it suspends, which means something is being fetched, it suspends, shows a fallback, and once it's figured out, okay, we're ready to show, it brings back the data. So this pairs with file system routing to do, this is kind of, if any of you have used Remix, has anyone used Remix here? Okay, it's kind of what an outlet does. It's basically, the process and the behavior, it's very similar. I'm not sure if Remix wraps it with suspense on the top level. I don't remember, I haven't done Remix in a year. They might do it in the background now that, unless React is still with all that crap of blocking suspense. I think they fixed it in React 19, but that's not a discussion for here right now. Index. So let's start looking into the components on how this thing works. So let's close this. We are rendering the index component, which is this one here. So we already know the process. We come here. It suspends. So I don't know if you're going to see it because it's very fast, but there was a loading spinner that would the loading placeholder would show up there. When we come into this route, we're going to have some stuff. Because we know inside of this component, we want to get our data for the on-call. So we want to show our on-call rotations who are currently in our database. So what we do is we use create async. So a create async, it's a primitive that Solid has, which allows you to turn a promise into a signal. So basically, it allows you to turn async data into signals. So we call the getOnCall function, which is the function which is responsible for getting our data from the database. Cool. Once we have that data, we use the for component from Solid to loop over each item and render it inside. So that's basically how we're going to see that entire list. And this is pretty boring in a sense, but now comes the interesting part. And this is kind of where you benefit from having Solid routed. For each route, we can tell it, hey, look, I know that this route is going to need the getOnCall data. We know that there's a data dependency for this route. Every time I'm coming into this route, I want to fetch that data. So what we can tell the router is, hey, look, every time you're coming into this route, you're going to need this data. So you can preload it automatically. So the route now, because of that, the router and the framework, the meta framework, are smart enough to figure out, okay, there's a dependency here. So if for instances, in this case, it's not going to happen because this is the index route, but on the next one, it's going to happen. If I over a link that is going to send me to a route who has a preload, that's going to call the preload function, and it's going to fetch the data automatically. So whenever we get to the route, the data is already there, and we don't have to refetch it. Now, by this, there's an issue right now, which is we have two function calls. We have getOnCall, and we have getOnCall. The function is being called twice. So in theory, it would be called on preload, and it would be called when it gets here. This is where the fun begins, because now, and some of you might have already seen this when I was over this function, we have this function wrapped with something called query. If any of you have looked into SolidStart, this before was called cache. We renamed it 3 weeks ago, 2 weeks ago, I don't know. It was very confusing, this being called cache, because some people would start thinking, oh, this is like 10-stack query. It's not. This query here, it's basically here just to say, this is a mechanism for avoiding resource deduplication. So the way it works is, this function is called. And when this function is called, the data is returned. And that data, when it's returned, it's cached, stored under this query key, which is on call, during 5 seconds or less. It kind of depends on the round trip, but the only reason why this happens is because if this is preloaded and we come here, so it's called on preload, and when it's called here, the data already exists. So the data was already, it's cached temporary. So it's a temporary cache, but it's not a cache. It's just a mechanism to avoid having to repeat requests a multiple of times. And it's pretty cool, because now we avoid having to have all this data being fetched a bunch of times, and it kind of saves us some time, because once we get to the component, the data is already there. I'll talk about this the next time we come here. Let's look into our ID. So our ID, it's our dynamic route. And our dynamic route process very similar, create async, and we call the getOnCall by ID. Now, we need to have an ID to fetch this data, so that's 0 or 1. It's going to come from our props. Remember, I told you, this ID is injected into the parameters of the props. So we got props, params, ID. So the reason why this is ID, it's because this is ID. If this was potato, this would be potato, whatever you want to call it. We then use it to call our function. Pretty much straightforward. When we have our data, we use the show component, and when we have our data, we display it. Pretty much the same process. We also do preloading here, and this is kind of the use case I was mentioning you. So if I open my network tab here, let's look into this. This is very small. If this is working properly, if I over the link, you should see that was a request that was fired, because the router is figured out, okay, this as a preload, so we know that this data is going to be needed whenever we come into this link. So now, let me just do it again. Request, I click, the data is already there. It doesn't repeat the second request, because the data was preloaded, and it was also cached temporarily during that round trip. Now, there's something inside of this function some of you might already recognize, which is something that Solid introduced in 2020, which is called useServer. So what useServer does, it's a directive for the bundler. So the bundler knows, hey, whenever you're bundling this application and bundling this part, the code that's underneath this useServer and in this scope must always run on the server, always. So what actually happens when we call a function that has useServer on it, the browser does an RPC call to the server executes the function and returns the data back to it. That's basically what useServer is doing there. It's telling, okay, the code that's executing in the scope underneath me must always run on a server environment. And this can be pretty cool. If you want, you can basically do database queries directly here without worrying about exposing stuff into the client, because everything that's here is not going to end up on the client bundle, and the client doesn't even know that this exists. Now, there's also something pretty similar that some of you might have noticed, which is there's also a query here, there's a query here. This is on call, this is on call. So it's the same query key. Isn't there an issue of between the same round trip or something like that, these query keys colliding? No, because of this. We have a parameter here, which is ID. And in reality, a query key, it's always the combination of the serialization of query key plus the parameter that the function receives. So that makes sure that there's no query key collisions in these use cases. And that's, I think, basically what I wanted to show you in this part. Okay, data fetching, preloading, trying to remember, we've seen this. Okay, let's go to forms. So forms are the staples of mutations on the web for plenty of years, and they should continue being. Forms are made for doing mutations, which means updating data on a database. And the way we do this, without having a form management library, is just by using the web. The form can take something, which is an action, and when there's a submission, this action is called. And the way this is going to work is, let's look into this. We know this is an action. First, because it's added to the action, but then because there's an action keyword here. What this action is doing, it's basically receiving the form data. So forms return form data. There's no need for state management for forms, if you're using forms. That's something that it seems like we've forgotten when we started doing single-page applications. But yeah, we get the form data. We extract our data from the form. Oh, this is a server action. So we know that there's a server function. This is an action. We have a server action. And then what we do is basically we just update our database. And because we don't want to stay on the same route where we just did the form submission, we go back to the index. We could even go to the route we just created. Here I took a decision to go back to the index. Now this is where the interesting use case shows up. Because, let's go back here. Let's picture what happens in our browsers and in our applications network tab while we're doing this, shall we? So there's a post, there's a submission. Then after the post, the action is executed, so the action is executed, whatever. We do a redirect. So we go back to our index, right? But then our index says, oh, I need this data. So the index does a request. So we're creating something which is called a network waterfall. So our browser, our application is going 1, 2, 3. It's the post, it's the redirect, and it's the data fetching. This is what traditionally happens when we have this behavior. So now I want to show you something cool. Let's keep our network tab open. Let's get this out of the way. And let's add a new user. Doing everything. Can be checkout. The user, no, I don't want Bruce Wayne now. Let's do Clark Kent. And let's add, it started 2 days ago, and it ends by the end of this week. So now, this second request ignore, because this is the one that came from me overing this, so this is the preload. But our submission was only one request. Where's the 1, 2, 3 I just mentioned? This is one of my favorite features that SolidStart has. This is called single flight mutations. Because your router knows all of the data dependencies of your application, it is smart enough to figure out, okay, if I just did a post, and inside of that post, then I'm going to redirect into the index, and the index needs that data, what it does is, when the post happens, it redirects back to the new page, it sends the page back, and then it starts streaming the data back on. So all in one request. Instead of having the post, the redirect, and the data fetching, it sends the new page, starts fetching the stuff on the server, and streams it back into the browser, all in one flight. Therefore, the name single flight mutations. Now, we have 9 minutes. We have 9 minutes, right? We do. I wanted to show you something, but I don't think I'm going to have time. So I'm going to give you homework if you want. There is this application, if it's live. I hope it's live. It was live when I tested it. I forgot the password. I'm going to register a new account. So any of you have used Trello before? So it's basically just a Kanban board. So that's basically what we built here. Blah, blah, blah. At blah, blah, blah. .com. Password is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We register. This application, and the code is all open source. This has been something that myself and some of the Solid DX team and some members have been working for the past few months. This kind of started as a challenge from Ryan Forens, the creator of Remix. So he was basically just roasting everyone online that built this version. And we were like, OK, we're going to build something that Ryan Forens is going to approve. So here we have basically a Trello board. And this is built with SolidStart. And this is leveraging fine-grained reactivity to the next level. We have stuff like, and this application has the example, which I won't show you, of progressive enhancement. Not progressive enhancement, as the example of, I forgot the name of what the thing I was going to show you. Optimistic updates, exactly. This does optimistic updates, which basically it means when a request is happening, so when a single flight mutation is happening, we update the UI so that the user already has immediate feedback. And when the data comes back, we reconciliate without having to kind of re-render the application, because this is so fine-grained that if this entire list changes, only the specific stuff that changed will be updated. The power of fine-grained reactivity. This is open sourced on GitHub, so if you want to check it, it's at Solid Community. Let me double check, because I'm on a negative community, GitHub. I was not planning on showing you this because I didn't think I had time. But if you come here and you choose Trello, you can check it out. You can look at the code. This is probably the biggest use case of fine-grained reactivity in SolidStart built to date, and the most complex one. So we spent hours building this. During the implementation of this, Ryan remembered he needed some new APIs from SolidStart, so he started building those APIs. It was a very fun project. So if you want to look at it, you can work. Oh, and I remember something, which has been a word that I was mentioning earlier today, which is progressive enhancement. Let's disable JavaScript, shall we? Let's run our application, and it doesn't work. Why doesn't it work? It's a single-page application, exactly. We have been doing all of these things from the perspective of the Create React app in the past. So all of these applications we've seen so far was a single-page application. So now, if we turn SSR, progressive enhancement, JavaScript is still disabled, right? So JavaScript is still disabled, and it still works because server-side rendering, and JavaScript should be there to do progressive enhancement, which means enhance your experience. not control it as it might happen throughout the few past years. Okay, so let's finish this thing, shall we? And I believe now we have seen pretty much all of those things. We've seen single-flight mutations, we've seen multiple render modes, we've seen single-page application, we've seen server-side rendering. We also have an experimental islands mode right now. It's called experimental because there's still a lot of stuff we're still working on. I'm not going to talk about server components because that's something for the future. Right now, we're actively working on Solid 2.0, which is going to change a bit on how fine-grained reactivity works. It should come out hopefully next year. Let's see. We've seen data preloading, data optimistic updates. We've seen them working, but we didn't see the code. But it's basically just using a function, a primitive called useSubmission, that whenever an action is on flight, useSubmission has access to that. We've seen progressive enhancement, server functions we've seen, server actions we've seen. We didn't see API routes, but API routes is basically just inside of our routes folder. We could create a function. So this is very similar to Remix if you've seen. You could say whenever there's a GET request for this component, for this route, you're going to do something. So this is a full stack framework. You can use this to build API routes. And we've seen request and resource duplication with the use of query. Okay, and in the last 4 minutes, it's going to take less. So what's the future of full stack frameworks? Well, the short answer is I don't know. JavaScript world is very inconsistent, and it's always changing. Every new day, there's a new JavaScript framework. They used to say a multiple of times. But if I could take a bet, it will start with full stack fine-grained reactivity. We are seeing this pretty much everywhere, except React. But there's a reason why React doesn't do it. We can talk about this after the presentation. But for some reason, every framework is converging around fine-grained reactivity. So it seems like having something that's fine-grained from the server to the client might be a good chance. And the second part is no lock-in. I think this has been one of the points we try to fully put emphasis while building SolidStart. It's having the choice, you having the choice as a developer, and without being locked in to deciding what you have to do. In these six months-ish months since the V1 of SolidStart was released, we already started seeing meta frameworks built on top of SolidStart. So in theory, they would be meta frameworks. But that's basically what we would like to see people do. Build on top of SolidStart, bring your own opinions for your use cases, and don't be locked into your decisions. So this might be one future. I'm not telling you that you have to go ahead and use it. At the end of the day, we have to use what we are paid to do, to use in a sense, but we can have opinions and we can take our choices and we can figure out. So use what you like, use what you love. That's my final message for all of you. If you want to check Solid and SolidStart, I'll gladly be available to talk with you either today, if we have time, anytime if you just want to connect with me online. And yeah, this was SolidStart, the shape of frameworks to come. Thank you so much for your time.